So what we were talking about was the relationship between aggregate expenditure and real GDP. In the diagram that we were drawing a moment ago, we saw that our consumption expenditure is an upward sloping function of real GDP. And if we increase any of the autonomous expenditure components, in other words, any of those exogenous variables, what happens is that the curve shifts upwards. Okay? So we increase autonomous consumption, we shift the curve upwards. We change the value of the intercept, we don't change the value of the slope of the curve, but by changing the value of the intercept, we change the value at which the consumption function and the 45-degree line intersect. In other words, the point where output and consumption are equal. So by changing autonomous consumption, we change the value of output that equals the value of consumption. The same applies to our aggregate expenditure function. Exactly the same principles. Our aggregate expenditure consumption is upward sloping. The intercept is determined by the autonomous components of aggregate expenditure, which is to say those exogenous variables. And any change in any of those autonomous variables shifts the aggregate expenditure function either upwards or downwards. What we have plotted in this diagram underneath our aggregate expenditure function is our unplanned inventory investment. Okay. The relationship between this function and this function is as follows. At point D, if we start at the point of equilibrium, are you happy that the level of planned expenditure, which is 13 in our case, is equal to the level of output 13? Okay? If our planned expenditure equals our actual expenditure, which is measured by real GDP, then our unplanned change in inventories is 0. Okay? 0 is our unplanned change in inventories. However, if we consider a point like point B, our planned expenditure level is 12. Okay? What that means is that going into this period, firms and all of this discussion centers around firms. Okay, we assume that firms are the only ones for whom unplanned changes have any effect. So firms have gone into this situation with planned inventory expenditure. Okay, so they've got some amount that they want to spend. We saw in the schedule our planned investment is 2, value of 2. Okay. At a point like point B, what happens is our actual expenditure is measured by the value of 11. Okay? So our actual GDP is 11. Our planned value of GDP is 12. Okay? If we only produced 11 of GDP to the value of 11, this is our actual GDP, this is what we actually produced. If we only actually produced 11, how can we spend a value of 12? Okay? That's the question here. We only produced 11, right? But somehow we managed to buy 12. Okay? And the reason that this happens in this model is an unplanned change in inventories. Okay? So what happened was we produced 11, firms wanted to invest a value of 2, households wanted to consume a value of 7.7, governments spent 2.5, exports were 2, and imports were 2.2. Therefore, our total spending was 12. How did we manage to spend 12 when we only produced 11? Because firms had an unplanned decrease in inventories. In other words, some of this expenditure is expenditure on inventories that were kept aside from a previous period. Does that make sense? We produced an output of 11. Okay, so what we spent was, in this 12, was we produced 11 plus we drew down inventories by a value of 1. Okay? How did we get inventory? Well, for example, when a firm invests, remember that investments, there's 2 components to investment. There's capital investment, not capital, whatever. There's a change in actual, put it this way. Investment is a change in capital, and a change in capital includes 2 things. Change in, for example, this is really difficult, sorry. A change in, for example, factory equipment. Ooh, this looks horrendous. I will rewrite this all afterwards. So factory equipment, also inventory. In other words, in any particular period, firms can keep some stock aside and it forms inventory. You happy with that idea? Yeah? So firms keep inventory aside and they plan to keep a certain amount of inventory aside. We could give, as an example, of this investment of 2, what firms really wanted to do was to increase equipment by a value of 1 and increase inventory by a value of 1. Okay? That's what they wanted to do as part of their investment. However, what's actually happened is they've increased equipment spending by a value of 1. They've tried to put an extra 1 aside, but because the level of spending is higher than the level of output, they've also had to take some inventory. They've had to take some investment out of inventory. In other words, their inventories have decreased by a value of 1. So even though they plan to put aside 1 to inventories, they put aside 1 to inventories, but they had to take 1 out of inventories. So what has their actual change in inventories been? 0, right? And if their actual change in inventory was 0, their actual change in spending on investment, they planned to spend 2, but they only actually spent 1. They had an unplanned change in investment. Okay? And in other words, an unplanned investment change. Let's look at it from the other side and see if it makes a bit more intuitive sense. Let's say we were at point E. At point E, how much did we actually produce? 13. Okay? How much of that we produced was actually sold? 13. So we're happy that whatever was produced was sold. Okay? They've moved point E. Okay, that's not. So this is the point E that they would be referring to in a sense. So let's cross that E out. That's not point E. This is point E. Let's cross that D out. Okay? Sorry. So in this table where they've got point E here, if we're matching it to this diagram, that would be point E. At point F, where we've got 14. Okay, so now this point E here is actually point F. Great. At point F, our real GDP is 14. Our actual expenditure is 13.5. So we've spent less, we've purchased, less than what we actually produced. Is everyone happy with that? So what happens if we produce more than we sell? What do the firms do with that stuff that they've produced and have not sold? it goes into their inventories, right? As it's now unsold output, it goes into their inventory. What happens? Well, they had an unplanned increase in inventory. Are you happy with point E that we've had an unplanned increase in inventory? So in the same way that at point E we have an unplanned increase in inventory because our level of spending was less than the amount required to sell all our output. So at a point like point A, at point B, or at point C, what happens? Well, our level of spending is greater than our level of output, which means we have an unplanned decrease in inventories. Now this is important for the firm. Why is it important? Because at a point like A, B, or C, inventories are decreasing. What that's telling firms is that the amount that they are producing is not enough for the level of expenditure that people want. What do you think that prompts firms to do? You've produced some amount, right? And you've sold it all, and in fact you've sold so much you've had to take from your inventories stock that you did not expect to sell. You've taken it out and you've sold that as well. You're selling more than you are producing. What does that prompt you to do as a firm? Produce more, surely, right? You're selling more than what you are producing, so much so that you're going into your inventories and taking stock out of your inventory that you did not expect to sell and selling that as well. Your inventories are decreasing in a way that you did not anticipate. What does that do? That prompts you to increase output. When you increase output, you move from, for example, a point like point C to a point D. At point D, you produce a value 12. You sell 12.5, which means you are still selling more than what you are producing. So what do you do as the firm? Produce more. So you move from point D, for example, to point E. And what happens at point E? You're producing 13, you're selling 13. You've got no unplanned changes in inventory. The amount you're producing is the amount that people want. Do you produce less? No. Do you produce more? Well, no, because what you produced, and it all sold. Exactly what you produced sold. You didn't have to take any extra out of your inventory. What you produced got sold. That seems to suggest you're producing the perfect amount. What happens if, for example, we were at point F here and we were producing 14, but we only sold 13.5? What signal does that send to the firm? Producing too much, exactly. What should we do? Reduce production, which moves us from point F down to point E. So what do we see in our diagram? Anywhere to the left of equilibrium is a signal to firms that they should produce more. And we move towards our equilibrium point. Anywhere to the right of our equilibrium point is a signal to firms to produce less. And so we move towards our equilibrium point. Is that a question? Yeah?
So I know in economics we always study about going to the equilibrium point.
Right.
But on the previous slide.
Yeah. You mean this slide?
Yes, on
Yeah.
the slide. So our aggregate expenditure ends up being more when we produce at 14. It ends up being 13.5. So we're in any way selling more than what we would sell, are we not?
Oh no, yes, we are selling more than what we would sell. Correct, but we are not selling what we're producing. We're not selling all of what we're producing. So then the firm's problem here is that it's produced too much. It's now got an unplanned increase in inventory. It's costing the firm to now put that stuff in inventory and no one's buying it. Yeah?
But still at the end of the day we're selling more than what we would if we produced less.
are absolutely correct.
So could we then, obviously, yeah, okay, this is economics and we're always going back to their point of equilibrium, but surely could businesses actually make a decision to store that inventory if they're actually making more profits when they're actually producing more than if they had 13 and 13 and sold everything?
Okay, remember from microeconomics, demand and supply, right? The price can go up, right? As the price goes up, you want to supply more. There's no point in supplying more if no one's buying it, right? So what is the point, and this answers your question, what is the point where the firm maximizes profit? This is the point where the firm maximizes profit. Not up here, even though it might, in this example here, be able to sell more, it's not the point where it maximizes profit. So it's in producing more and selling more, it's actually making less profit. Even though it's selling more, it's making less profit. Okay? So that's what the movements along this curve are saying. That the firm is going to do best at point E. It could sell more, but it's selling more at a loss or at a lower price or at less profit. So it doesn't make sense for the firm to be there. Okay? Yeah, what else? Any other questions? No? Are you happy that it's this distinction between planned expenditure and actual expenditure which drives the dynamics of this system? Anywhere along this aggregate expenditure curve gives us the level of planned expenditure, right? Anywhere along this 45-degree line gives us the level of actual expenditure. So the difference between our aggregate expenditure curve and our 45-degree line, which is measured by this distance here, that distance there is this distance here, right? That gap between planned expenditure and actual expenditure is what causes movements along the aggregate expenditure curve to our point of equilibrium, where actual planned expenditure equals actual expenditure. In other words, where GDP equals aggregate planned expenditure. Everyone happy with that or not? Okay. So equilibrium will be at this point of intersection. So if we look at this diagram, we see at any point A, B, or C, there's an unplanned change in inventories that's negative. In other words, inventories are decreasing, and firms did not anticipate it. We are selling more than what we are producing. At point D, it's equal. Points E and F, well, that point E and that point F, we've got inventories increasing in a way that we did not anticipate because we are not selling what we thought we would sell. Okay, so that's the dynamics of this system, and that's how it works. What happens when we have a change in any of the autonomous components? Well, we have a shift in aggregate expenditure. The same as what we saw in our, when we plotted our consumption function. When we increased the autonomous consumption, we shifted the entire consumption function upwards. When we increase any of the autonomous components of aggregate expenditure, we shift aggregate planned expenditure. How does this model then work? Are you happy that with aggregate expenditure level AE0, our point of equilibrium is at point B, and our real GDP equals 13, our aggregate planned expenditure equals 13? Okay? Let's say there's an a change in government spending, a change in autonomous government spending. Government spending, instead of previously spending, say, 100, they now decide they want to spend 150. What does that do to our aggregate expenditure curve? It shifts it upwards. And we are now at point B prime. At point B prime, on aggregate expenditure level AE1, are you happy that AE1 intersects our 45-degree line here at point D prime? Right? Now, compare this point here, point B prime, to point D prime. At point B prime, we are to the left of this point here, this equilibrium point. What is going to be happening to firms' inventories at point B prime? Are you happy that there would be an unintended decrease in firms' inventories? Right? They plan to produce a certain amount. Government has now decided they want to buy more. Firms are now selling more than what they expected. Their inventories are decreasing in a way they did not anticipate. What does that prompt the firms to do? Produce more. And in firms producing more, what happens to our level of output? It increases. And that increase in level of output moves us from point B prime to point D prime. It stops at point D prime. Why? Because remember, if firms produce anything more than D prime, they get an unintended increase in inventories, and they know they've therefore produced too much. So they cut back. It's only at point D where they are selling what they expected to sell, where they are maximizing their profits, and where their intended sales are equal to their actual sales. So we move from equilibrium point B to equilibrium point D prime. Everyone happy with that idea? Okay. Why does it do that? Through something called the multiplier. In other words, we've increased aggregate expenditure by a small amount. Aggregate planned expenditure is increased by a small amount, yet output has increased by a large amount. Okay? Because of the multiplier. The multiplier has a value greater than 1. Why? Because induced expenditure increases, and an increase in autonomous expenditure induces even more increases in expenditure. Right? What are we talking about? Remember our equation? This is a good spot. Remember, C equals A plus BY. If we increase G, an increase in G increases Y. An increase in Y increases C. An increase in C increases Y. An increase in Y increases C. Increase in C increases Y. Y. Okay? Right. That is why when we increase our aggregate expenditure by a small amount, it leads to a big increase in output. Right? Because we have induced expenditure, so an increase in autonomous expenditure induces further increases in expenditure. Right? So this is going to look dreadful, but remember, C equals A plus BY. So when Y increases, C increases. But when C increases, Y increases. Right, so then we want to calculate something called the multiplier. How does the multiplier work? Let's do this in a bigger space. And let's get another layer here. Okay, so here's our equation. Y equals C plus I plus G plus X minus M. And we know the consumption is A plus B times Y minus T. For now, let's just let taxes equal 0, let imports equal 0. We can change that just now. Our equation, therefore, we can write this equation as y equals a plus by plus I plus g plus x. Okay? Now, let's say we want to change g. Okay? If we change g, it's going to have some impact on y. It's going to change y. Correct? But the way that our equation currently sits, if we increase g, for example, that increases y. However, that increase in y also increases y, which increases y, which increases y. So how do we solve for y? We've got an equation where the variable y is on both sides of the equation. How do we solve this equation for y? Well, we need to get y on both sides. Rearrange. You happy with that? Got a common factor here. Y times 1 minus b equals a plus I plus g plus x. Therefore, y is equal to, we can divide both sides by 1 over 1 minus b times a plus I plus g plus x. Okay? Now, if I want to change g, and I want to know what's the effect on y, well, now it's quite straightforward. I've got an equation that is a linear equation, so it's in the form y equals mx plus c. That's what I got here. Okay? Except that obviously, in this example, x is a plus I plus g plus x. M is 1 over 1 minus b, and c is obviously 0. So if I want to know what is going to be the change in y if I change x, well, I know how to do that. It's change in y over change in x equals m. Okay? So what's it going to be in my equation here? Change in y over change in g equals m. What is m? 1 over 1 minus b. Okay? So let's, give b a value. Let's say b equals 0.5. And let's say the change in g was 5. Okay? Well, change in y is equal to 1 over 1 minus 0.5 times 5. 1 over 1 minus 5 is 2, so 2 times 5 equals 10, which looks a lot like what we saw just now. Oops. Right, what happened? We changed our value of b was 0.5. We changed a by a value of, by an amount of 5, and the change in y was 10. I said that the reason that y changes by more than the change in a is because of something called the multiplier. This here, this thing, 2, is the multiplier. This value here. In other words, this whole thing here is called the multiplier. Given that our equation is just a straight line function, the multiplier is the value of this m. Okay? So when we change x by something, y changes by some amount, m times x. In other words, 1 over 1 minus b times change in any one of these autonomous components. Now you see that the slope of our consumption function is what's going to determine the size of the multiplier. If the value of b increases, then the value of the multiplier does what? If b goes from 0.5 to 0.75, what happens to the multiplier? It increases. You happy with that? The steeper the slope, right? Okay? Steeper the slope, the greater the multiplier. Okay, so this is our multiplier, 1 over 1 minus b. Except we can make our multiplier far more complicated. So 1 over 1 minus b is our multiplier. Now b was the induced the parameter of the induced component of our consumption function. In other words, c equals a plus by. Okay, so the b was the induced, came from the induced portion of our consumption. B is the only induced parameter in our equation, right, where we had taxes 0 and m being 0. Let's make this more complicated, this equation here, and we'll see how that changes our multiplier. Even though our multiplier changes, the intuition behind what we're doing remains the same. So now let's let taxes equal two different types of, there's two different aspects to our tax. There's going to be an autonomous tax component plus an induced tax component. Okay? This we call, for example, a lump sum tax. All of this, by the way, is in the appendix to this chapter 27. So this is a lump sum tax, and this, an example of an induced tax would be, for example, an income tax rate. Income tax rate. Okay? Let's make the income tax rate 10%. Is there a reason that we're listening to tunes? Because if we're going to listen to tunes, I would like to have an input as to what we're listening to. No? Oh, okay. All right. Okay, let's say the income tax rate is 10%. Okay? What is going to happen to our consumption function? Our consumption function is now a plus b y minus t. Okay, which is going to be t is now going to be two different components. Okay, we're going to have b times y minus ta and minus ti, but ti is induced and it's 10% income tax rate. In other words, it's going to be 0.1 of our income. So this is going to be b times y minus ta minus 0.1y, which means we've got b, let's let's not give it an exact value of 10%. I'm going to call this, let's just call this little thing here little t. So, yeah. Oh, sorry. Yeah, you're right. C equals. Cool. Okay. So C equals A plus B times Y minus TA minus TY. Okay. And let's also now expand on our imports are going to be induced. Okay. So induced. So what we're going to say they're equal to is a little m times y. Okay. So what does our expenditure equation look like now? Y is equal to A plus B times Y minus TA minus TY plus I plus G plus X minus little m y. Okay? Cool. What I want you to do now is calculate the multiplier. Sorry, so a bunch of people saying you don't know how to calculate and multiply, right? What is the multiplier? I mean, can I just recap? Y equals mx plus c, right? What is the multiplier? It's this thing here, m, in our straight line equation. So in other words, when we had the equation y equals a plus by plus I plus g plus x, what I wanted to do was solve for y, which means I have to put y, right? I have to isolate y and put y on the left-hand side of the equation and get it out of the right-hand side of the equation. That way I can solve for y. So I rearranged my equation to get y by itself. Okay? And I ended up with 1 over 1 minus b times a bunch of variables. Each one of these is an autonomous variable. In other words, a change in any one of these variables is going to affect this variable. So what we've got is a straight line equation for a straight line, except that instead of just one little variable x that affects y, we've got a whole bunch of variables that can affect y. Either way, they're all beholden to the same relationship. This is the multiplier. This is the slope of this curve. Whether I plot y against a or I or g or x, I'm going to get the same straight line relationship. So when I change one of these variables, I change output. I change output by an amount of, well, whatever the change in that variable was, multiplied by the multiplier. Change in y times change in g equals this coefficient, 1 over 1 minus b. So I need this equation in this form to get a multiplier. Now I've got the equation in a slightly extended form, and I'm asking you to do the same thing. Rearrange the equation, get y by itself on the left, tell me what the multiplier would be. Okay? Yeah. No, just what it would be. Like, tell me what the what form it would take, I guess. When you say the previous one, you mean the previous multipliers, yeah? Okay. Okay. Your confusion therefore stems not from economics but from mathematics. Okay? No, I mean, what I'm saying is don't feel disheartened by your economics knowledge here, because this is not your ecos that's letting you down. It's your maths. Okay? Y equals mx. No, I'm saying I wasn't going to teach you maths principles, right? But if I wrote this equation as a straight line graph, y equals mx, and I'm going to let c equal 0, right? The way I would plot this is x, y, slope, m, right? Okay? Now, if I want to plot y equals m x plus z, right? If I plot y against x, it's still going to be the same. It's an m slope. If I plot y against z, it's going to be the same, m slope, right? And if I plot y against x plus z, it's going to be the same m slope, okay? Now, when I change in this equation x, okay, z is constant. So if z is constant, I can write this equation in the following format. Y equals mx plus m constant z. In which case mz takes the form of c. Right? I've now got y equals mx plus some constant. Now if I want to know what happens when I change x, change in y by change in x is equal to the constant. I'm not interested in the constant because the x does not change the constant, right? It only changes y, and the change in y will be m, regardless of the constant.
So because all the other variables like a, I, x were autonomous, we assume that they're constant.
Not we assume, that's the definition. They're autonomous. When I change one of the other variables, nothing happens to any of the other variables. Sorry? Yeah, so another term for autonomous is exogenous. So exogenous means that the value that they are set at is not determined by what the model equation is telling me. Okay? So if I change any one of those variables, it does nothing to any of the other ones because they are all exogenous to this model. Only endogenous variables will change. Now C is an endogenous variable, and we've just said that M is also going to be an endogenous variable, right? So what we see when we write out our equation in this advanced form is, here's our C. We see that it's induced, okay? So we've also said that taxes are going to be induced, and we've said that imports are going to be induced. So they've all got little y's on them, okay? Which means if I change I, G, or X, it impacts on C, it impacts on T, and it impacts on M. Doesn't impact on any of the other constants. Okay? Cool. Maybe we should just get to the answer here, because our time is running out. We rearrange this equation. If I just skip to the final answer, you'll just have to double check that I'm doing correctly here. You're happy that we're going to have 1 minus b, I think it's plus b t and minus m. Oh, is it plus m? Yeah, sorry, you're right. Plus, 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 cool. Okay, good. Times a plus I plus g plus x, right? Oh, sorry. Yeah, you were right. Good. Maybe I was just testing you. Minus b times ta, right? Plus x. Okay, everyone happy with that? No? Would you like me to talk more about it?
I got a similar answer.
Okay.
My BTA was at the bottom.
This one.
Yeah.
Okay. BTA, does it have anything to do with y? Did you take it to that side as though it had a y?
Yes, I did.
Okay. So in our final answer here, are you happy that all the autonomous components, so here's all our induced components, there was a B and a T and an M, all of them end up in our multiplier, right? Are you happy that by introducing a T and by introducing an M, we have made the value of this multiplier, right, the value of this number down here, bigger, right? So if we've made this number bigger, we've made the multiplier itself smaller, right? So what we have done effectively is, by making this multiplier here smaller compared to the multiplier here, are you happy that in this diagram, what we've done is we've changed the slope of our aggregate expenditure curve relative to real GDP, right? The slope is no longer simply B. The slope is B and T times B and M, right? All of those things together now determine the slope, okay? And so this is why our curve shifted or swiveled when we included autonomous imports, because we've now got a different multiplier process. Yeah.
Is it not a problem to pick up little b in our x?
Here. No, that's not a problem at all. It can be there. Remember, it's the same as the question that cool, let's go with that. That page was asking, right? There's a multiplier with Z, right? But the multiplier on Z is a constant if we're looking at X, right? So the same, we've got a B here with T, but it doesn't affect any of the other variables, it's just a constant. Okay, cool. Okay, everyone happy with that? Well, I say happy, maybe that's the wrong word to use. Then what we'll do, we'll leave it there. We haven't quite finished these slides. Still got a little bit of a way to go, but we've done most of the important stuff. So we'll pick this up not next week, but the week after the test. So after the test, what we'll do is we'll go through the test, and then we'll carry on with our work. We'll finish this off, and then we'll finish off any of the money stuff that hasn't been finished off, and hopefully we will be on track.